Okay, so let me share my screen. I believe my screen is visible, right?
Yes, sir.
Okay. So I believe we did question till question number 15, right? We have to do after that. Okay. So let's just start. There is question number 16. Let Z denote the set of all integers and A is goes to A square plus 3B square is goes to 28 and A and B both belongs to what? Z. Z is what? Z is what? Set of
Whole number.
integers. Z is always represents integers. Okay. So A and B both belongs to integers. Here also A and B both belongs to integers. And where A is greater than B, then the number of elements in A intersection B is. Okay. So there can be infinite number of elements in B, right? So it will all depend on set A. So can you solve for set A? A square plus 3B square is equals to 28. Are you guys solving?
Yes.
Okay.
Two elements.
How did you get two elements?
I tried to put values. I got like max value. I got 5.
Mhm.
5 square is 25 and plus 3 equals to 28. So B would be 1.
Okay. See, how many values I can put for B? Like suppose I have A square plus 3B square is equals to 28, right? So after putting the value of B and subtracting from 28, A square, there should be a number which should be a perfect square, right? So if I start with B is equals to 0, can I put B is equals to 0? I cannot write. B is equals to 0, so this will be 0. So A square is equals to 28, and that is not a perfect square. So B cannot be equals to 0. Then I put B is equals to 1. So this will be nothing but 3, right? So A square is equals to what? 25. So for B is equals to 1,
25.
I'll be getting two values, 5 and minus 5, right? Yes. And then for
Yes.
minus 1 also, I'll get the same thing, 5 and minus 5. Yes. So I've already
Yes.
got
Yes.
4 values. Now let's put B is equals to 2. If I put B is equals to 2, so this will be 2 square, that is 4, 4 3 is 12. So for B is equals to 2, I'll be getting A square is equals to 16. And for a square is equals to 16, I'm getting the value 4 and minus 4. Similarly, for 2, if I'm getting 4 and minus 4, for minus 2 also I'll be getting 4 and minus 4. Yes. Now let's put b is equals to what? 3. 3 is equals to what? 3 square 9, 9 3 is 27. If I subtract from 28, I'll be getting 1 and minus 1. Similarly, if I put minus 3, I'll be getting 1 and minus 1. Yes. Now, can I put b is equals to 4? 4 square is equals to 16. 16 3 is 48. So 28 minus 48, that will be a negative value. And that will not be valid. So till now, how many pairs I have got? 12, right? I've got 12 pairs till now. Now, I have to choose when A is greater than B. So that can be 5 comma 1. Yes, 5 with 1 minus 5 with 1. That would not be possible. Then I can take 5 with minus 1. Can I take minus 5 with minus 1? No, because minus 5 will be lesser than minus 1. So that is also not possible. Now, can I take 4 comma 2? Yes. Can I take minus 4 comma 2? No. Can I take 4 comma minus 2? Yes. Can I take minus 4 comma minus 2? No. Then for 3 I got 1. That is not possible. So 1 comma 3, that would not be possible. Minus 1 comma 3, that would also be not possible. Then 1 comma minus 3. Is it possible to have 1 comma minus 3? Yes. Can it be possible minus 1 comma minus 3? Yes. So I got total 6 pairs. Any doubts?
No, sir.
No? Pritish, do you have any doubt?
No.
Okay. Let's move to the next question. We have A is goes to something this, B is goes to this. N is the universal set. N is natural number. That is the universal set. Now it's asking about A dash union A union B intersection B dash. Okay. So before finding out the value, before like putting the value of A and B, let's just simplify this thing itself. Yes. And that will be what is A union B intersection B dash?
A.
A union B intersection B dash. B dash means what? Outside of B, right? And A union B is what? This whole boundary, right? So what is common in between them? This is A union B and B dash is outside B. Outside B. So what will be common? Not A. That portion of A which is not in B. Right? A minus B basically. Yes or no?
But yes, sir. But these two set are disjoint, where A is odds and B are evens.
For now, yes, the values are given like that only. But like we can take in general like this, yes?
Ah, yes, yes, yes.
Yes. Then we have to make the union of the same thing with A dash. So if I take the union of the same thing with A dash, and A dash is what? A dash is outside of this portion, right? So if I combine with this thing with outside of this portion, so that will be nothing but U minus A intersection B, right? Can I say? I have to take all other portion except this A intersection B, right? So that is nothing but U minus A intersection B. And because there is nothing in A intersection B, so this will be U itself, the universal set, and that universal set is natural numbers. Yes?
Yes, sir.
No doubts, right?
Yeah, no doubt.
Okay. Okay, just give me a second. Okay. Let's take another question. Question number 18.
Seven.
7. Okay. What about you, Pratish? Pratish, are you getting the same answer?
I'm still working on it.
Okay. See, there are two tests, right? And it's saying that 50% of the students failed in test one. If 50% of the students have failed, so obviously 50% of the students has passed, right? So the number of students who has passed in test one would also be 50%, right? And 50% of 70 is nothing but 35. So the number of students who passed in test one is 35. Yes, number of students who passed in second test would be what? 40% have failed. So 60% would have passed, right? So 60% of 70, that would be 42. Now, number of elements in first intersection second, that will represent the number of students who passed in both the tests, which we don't know. Yes. And total number of students, that is 70, right? So 35 plus 42, that will be 77. So 77 minus 70, that would be x. So x is equals to 7. Yes. Any doubts? Any doubts?
No, sir.
No, sir.
Okay. Let's move to the next question. Let U be the universal set for sets A and B such that number of elements in A 200, number of elements in B 300, A intersection B is 100. Now it's asking you number of elements in A dash intersection B dash. Achha, that is also given 300. Okay. Then it is asking you number of elements in universal set U.
Seven hundred.
700. Yes, that's correct answer. So number of elements in A is 200, B is 300, and A intersection B is 100. So the total A union B, the number of elements in A union B will be what? 200 plus 300 minus 100, right? So total elements in this particular section will be 400. 300 plus 200, 500 minus 100, that is 400. Yes. Now it's given A dash intersection B dash. So A dash intersection B dash is nothing but what? A union B dash, right? A union B dash means what? This outer portion. And this outer portion is given as 300. So this periphery includes 400 elements and this outer area includes 300 elements. So the total elements in this universal set would be 400 plus 300, that is 700. Right? Any doubts? Anyone? No, I believe, right?
No, sir.
No.
Okay. Let's move to question number 20. A, B, C are three sets such that A intersection A is a subset of B, B is subset of C, then A union B union C minus A intersection B intersection C.
C.
C option, right? A is superset of B, right? And B is superset of C. So what is the biggest set? The biggest set is A, because elements of B and C are already included in A. So if you'll do the union of A and B and C, ultimately you will get A itself. Yes, because that is the biggest set. Now, if you're doing the intersection of A, B, and C, you will get the smallest set. Yes, and that is nothing but C. So the answer would be A minus C. Yes, C option. Okay, now let's move to the next question. This is your question. An investigator interviewed 100 students to determine the performance of the three drinks, milk, coffee, and tea. And this. The number of students who did not take any of the three drinks is. So for this, You have to create the Venn diagram for 3 sets, right? Try this question.
Twenty.
20. Okay, Pratish. How did you solve this? Using Venn diagram, right?
Yes, sir.
Yes. Let's suppose this is milk, this is tea, this is coffee, right? Now, 10 students like all of them. So this is 10. Yes. Now, mm, 20 students take milk and coffee. Milk and coffee, that is 20, right? So only milk and coffee, that would be 10 itself, because I have to subtract the common thing also. Yes. This total sum, milk and coffee, this total sum is 20. Yes. The 10 is common to all three of them. So I'm writing only 10 in the common portion of milk and coffee. Then 30 students take coffee and tea. Coffee and tea is 30. So it should be, if it is 10, so this should be 20, right? And then 25 students take milk and tea. So 25, right? So if it is 10, so it should be 15. Now, 12 students take milk only. So this is the portion of only milk. Then 5 take only coffee, and 8 students take tea only. Yes. So we need to find out what is the number of students who didn't take any, right? So we have been given that the total set, this total universal set comprises of 100 elements, right? So we'll find out what is inside this whole boundary, and that will be nothing but the sum of all these elements. So 12 plus 15, that is 27, plus 8, 35, 35 plus 40, that is 75, plus 5, 80. So this whole boundary consists of 80 elements. So outside of this boundary will be 20, right? That's how 20 is the correct answer. Okay, now let's move to the next question. This is the same kind of question. Although any number is not given, you have to suppose this. You have to solve this by taking some random variable x.
Sir, could you just go back to the previous slide? I just need to take a screenshot.
Okay. Okay. Do you still have any confusion in this?
No,
Okay.
thank you, sir.
$77.
77. How did you solve this?
In the whole Venn diagram, I got all x. So the number which is divisible by 7 would be the answer.
Yes, absolutely correct. So what we'll do, the number of elements given in each section is nothing but x, right? As per the question, each section would consist of the same element. So if I add all these values, this will be nothing but 7x. So whatever is the answer, that should be multiple of 7. And multiple of 7 is only one option, that is 77. That's why this option is correct. Yes. Okay. Pratish, do you have any doubts in this particular question?
No.
Okay. Let's move to the next question. A intersection B is 5, A intersection C is 7, and intersection of all three sets is 3. Then the minimum possible value of B intersection C is
3.
3. Yes, it should be 3 itself. Why? Because we have A intersection B5, A intersection C7, and it is asking about B intersection C. So we can have that number of elements which is common to all of them. Yes, and the minimum number of elements which can be common to all of them, it can be 3 itself, not more than 3. Yes, because 3 elements are there which is common to A, B, and C, all 3 of them. So obviously, B intersection C should also be 3, not more than 3. Right? I believe in this particular question, don't you have any doubts? Let's move to the next question. And you can stop me anywhere, like if I'm fast for the questions. Okay? Should I move?
Yes.
Okay.
Yes.
Let's take this question. Number of elements in universal set is 100, Na is equals to 50. In B, we have 20. A intersection B is 10. And it's asking about A union B complement.
$40.
40, right? This is the same type of question which we have done earlier. So number of elements in A is 50, number of elements in B is 20, and common to both is 10. So the number of elements in this whole union will be 50 plus 20, 70 minus 10, that is 60. So this is nothing but 60. So outside this boundary, we will be having how many elements? 40, because the total number of elements in the universal set is 100. So A union B complement, that would be 40 itself. Now, Let's have another question.
Thirty.
30. Yes, that's a great answer. Here, how we can solve this? A and B both will be disjoint set, right? Any person would have voted only for A or B, right? If 20% have not voted for anyone, so obviously the percentage sum of A and B, it should be equals to 80%, right? And A is nothing but X, and that is X plus 20. So the sum of these X and X plus 20 should be equals to 80%. So 2x is equals to 60, so x is equals to obviously 30%.